So basically, this Java memory model specifies. So what is a memory model? So basically, we already know that memory model is generally considering, because when we are creating any objects, or so it is creating any. We are allocating a memory basically, right? And then whatever objects you are creating, whatever code you have written, so it is basically uh, consuming the memory. So when you are going through sessions, you will identify that when you are defining a particular integer types or data types, there is a space is basically consuming for each and every variables. When you are writing any methods, then it is also consuming the particular flow and everything like that, it is consuming it. So basically that variables like integer is consuming a 2 bytes like that. So if you will boolean is consuming a 1 byte. So based on that, you will have that understanding that memory, how the memory is getting allocated here. Okay. Then when you have this big program, so if you are processing a list or big processing, you are doing it through a file or other things, then you need to very much be careful about how the memory is getting utilized here, and how you can clean the memory, because major problems coming through the memory as well. And if you are going for an interview also, these questions are very much arises, and people are so many times asking for Java memory models. It is not very much at the fresher level, but at some experience level, these questions are very frequently getting asked, right? But if you have a good understanding of the concept for how the Java memory model works, then it will be really better. So in earlier days, if you know that there is a constructor and destructor in C plus C, right? So in C, where you have a destructor to deallocate the memories, and if you will use that, you can say either. So destructor and constructor concept in C++, but in earlier in when we talk about C, we have that malloc and calloc for the allocating the memories, right? And for deallocating also there is a one function. So you need to clear the memory, and it is very much required. Otherwise, it is every time consuming the memory. But Java memory model works differently. Okay. And here we also have that garbage collectors here. So first we will understand what is the Java memory model. So Java memory model is specifically how the Java virtual machine works, and the computer memory, basically RAM, as a random access memory. The Java virtual machine is a model of a whole computer. So this model naturally includes the memory model is a Java memory model. Okay. It is important to understand the Java memory model if you want to design correctly behavior concurrent programs. So as I already said, that when you are working on that high performance programming, or when you have a multi-threaded code, then it is very much important to understand it. Okay. Concurrent programs means when concurrency is basically is the multi-threading, you can say. When we have a concurrent leave, multiple tasks are getting ready. So Java memory model specifies how and when different threads can see the values written to shared variables by other threads, and how to synchronize access to shared variables when necessary. So this Java memory model is also coupled with your basic programming, as well as is very much important when you are understanding the threads. So basically here we are also going to discuss some sort of a threadings also. Okay. Because there is a volatile variables, there are atomic integers, and each thread is maintain its own stack. So it is storing the variable inside it. So how this you can this internal memory model works basically, right? When we are talking about threads, and when we are talking about the memory allocation, the original Java memory model was insufficient. Okay. So the Java memory model was revised in JDK 1.5, and this version of the Java memory model is still in use in Java 8. So basically, this Java memory model got revised in JDK 1.5 in Java 1.5, and still it is same available in with the JDK 1.8. So that is the basically you need to understand. Before JDK 1.5, it was very not very much sufficient. It was not very much profound. So the internal Java memory model. So the Java memory model used internally in the JVM divides the memory between the threads stack and the heap, as I told you, right? So the diagram illustrates the Java memory model from the logic perspective. So Java threads stack and thread stack and heap. So basically, heap is basically a class level variables that is generally stored in the heap. Always you note it down. All the variables which is basically stored at the class level, these are stored in the heap. Okay, when you are storing any variables at the heap, basically it is just shared variables, right? So earlier also I have one advanced threading sessions, I have described some sort of memory these problems which is generally coming into a multi-threaded environment when you have published the variables or class level variables basically. Okay, but here you will understand related to memory model as well. So each thread running in the Java virtual machine has its own thread stack. The thread stack contains the information about what the method the threads has called to reach the current point of execution. So basically there is a method calls also maintained inside the thread stack. Okay. So I will refer to as a call stack. So means the method calls which we are saying it. So in one thread you are starting, there can be a multiple functions you are calling from multiple classes. So in that case, you can say these are a method calls. As the thread executes its code, the call stacks changes. So are you guys are with me so far?
Yes, sir.
So
Yes, Ashish. Yeah.
yeah, great. So basically, maybe these things are not very much. You will have some questions as well, and we will. I will address it. So the thread stack also contains all local variables for each method being executed. A method can only access its own thread stack. So local variables, basically local variables means the variables inside the methods, okay? Variables which we have introduced inside a method or inside the functions created a thread are invisible to all other threads than the threads who created it. So basically all the variables inside the functions and they scope inside the method, these are called as a local variables. Even if two threads are executing the exact same code, the through two threads will still create a local variables of that code in each own thread stacks. So let's say is one function has one variable and one thread is calling that function and another thread is also calling the function, irrespective it is synchronized or not. So both threads has its own thread stack, okay, and it will create own local variables like that. So thus each thread has its own version of these local variables. Very important points. Each thread has its own version of a local variables. All local variables are primitive type, boolean, byte, short, character, integer, long, float, tuples. These are basically data types in a Java. Are fully stored on the thread stack and are thus not visible to other threads. So one thread may pass a copy of a primitive variable to another thread, but it cannot share the primitive local variable itself. So basically, one thread may pass a copy of a primitive variables to another. So copy of a variable then basically, but it cannot share the primitive local variables. Okay. So the heap contains, heap is basically nothing but class level variables generally stored. So that is a heap area which we are seeing it. So heap contains all objects created in the Java applications, regardless of what thread creating the objects. Okay. They include the object version of a primitive type. Okay, so basically, if you have any object version also, that is also created into a basically an heap. It does not matter if an object was created and assigned to a local variable or created as a member variable or another object, or object is still stored on the heap. So it is irrespective to object was created or assigned to a local variable. Okay, or created as a member variable or another. A member variable is nothing but basically class variable. Okay, if you are creating any object which is a basically class level but you are assigning to a local variable, still basically it will be you can say available in the heap. So you can just understand basically the entire concept in the programmatically manner. Here the diagram illustrating the call stack and the local variable stored on the thread stack and object stored into a heap. So there is a three things we are discussing here. One is the call stack, means how the methods calls is getting stored inside the thread, and how the local variables are stored on the thread stack, and how the object is stored on the heap. Okay, basically these are very important concept. If you are understanding very much carefully, then you will understand also threads and the why the major problems are coming when you are using a threads. That is also is getting clear here. So this is a thread stack one, method one, thread stack, right? So these are two thread stacks, and this thread is also calling method one, this thread is also calling method one, this thread is also using a method two, and this is, so both threads are using method one and method two, but they are maintaining their own copy local variables like that. And this is the heap area where we have created the objects basically. Okay, so this is the basically heap area. So this is a basically a JVM memory model. Now let's take into a further next level. So I hope you got the point for this concept for how these variables are stored and how the methods call is stored in the basically thread stack. So a local variable
Yes.
may be a type of primitive, that is we already discussed, or maybe you can have also created any other class objects also, in which case it is totally kept into a thread stack. So local variables basically which is created again inside a function or method, where may also be a reference to an object, means there can be also other class of object also you can create inside a method, basically that is called, we are taking as a reference to an object. In that case the reference, the local variable is stored onto a thread stack, but the object instead itself is stored on the heap, means the object is stored inside the heap, but when you are referencing to a local variable, so basically that reference is stored into a thread stack, right? Let's say class A and class B. If you are creating a class B, referencing a class B inside any method inside a class A, right? So if you are calling that method print, and you are calling that object B inside print, right? So that is a basically which you are talking about. So a object may contain a method, and these methods may contain a local variables. So any class, and if you are creating an object of that class, so in that case method and method will contain the variables, that is we are trying to describe it. These local variables are also stored on the thread stack, even if the objects and methods belongs to is stored on the heap. Okay, so this is a basically now we are just going to one more level up when we have creating a object of any other custom classes, and the custom class has methods as well as the variables, locals as well as a class level variables, that is we are talking about. Earlier we are discussing about just the primitive types. So a object member variables means class level variables are stored on the heap along with the object itself. So when you are creating an object of a class, that is also stored into a heap, and all the member variables are also, which is the class level variables, is stored inside the heap. That is a true both when the member variables of a primitive or maybe any other object. So either it can be a primitive type or maybe any other object type like that. So static class variables are also stored on the heap along with the class definitions. So basically static class variables. So static variables also very important point. Many times interviewer can ask to you how the static is behaving like this, where it is stored like that. So you need to understand. Okay, and it is static is the concept of a static very much important when we are discussing about the your memory models, right? Because statics are not belongs to any object, it is directly belong to a class level, right? So when we are talking about locking, so locking is also two type, one is a object level, one is a class level when we are talking about multi-threaded environment, right? So these static concepts are totally different. You need to very much you need to understand the concept very clearly when we are working with the static methods and static variables. So objects on the heap can be accessed by all the threads that have a reference to the objects. When a thread has access to an object, it can also get access to that object's member variable. So when you are any thread is using the object, then definitely through object you will access its method and the variable. There is nothing any difference here. If two threads call a method on the same objects at the same time, then will both have access to a object's member variable, but each thread will have its own copy of the local variable. Yes, it's a very important concept. If two threads, let's say two threads are accessing same objects at the same time, and then will both have access to objects member variables. So, but each thread will have its own copy of a local variable. So that is a problem here, because thread A reading at the same time of a class A variable name is, let's say, count, and count is 10. So thread A is trying to access of an object of A and accessing a count is 10. Thread B is also trying to access at the same time, but this count variable is shared. So there will be an ambiguity and there will be a problem of this reading of a counter variable. That is, so that is a basically very much related problem where we use the volatile as well as the atomic integers. Okay, because this one class level variables is shared in access by the two threads, and each thread is maintaining its own local copy and working on local copy, so that other threads are updating that variable counts. So other thread will never be able to you can say get the updated value. So because of this concept, you can understand why it is happening here. Okay, here is diagram, you can see like this. So thread stack, local variable, okay, local variable is basically nothing but object 3. Here method 2 has a local variable object 1. Here is method 1, local variable is 1 and local variable is 2. So this is the way. So in thread stack, second thread stack, local variable 2 is also accessing a thread object 3, and here is also we are accessing this local variable 2 is also referencing the thread object 2. So both are using the thread object 3. So now this is shared by these two threads and they are maintaining the local copy. So two threads have a set of local variables. One of the local variables is local variable 2, okay, which is referencing to object 3. So object 3 you can consider is a one of the class, which is a class B, you can just take it as a reference. Point to a shared object on the heap. Okay, so the two threads each have a different reference of the same object, and that is a basically a sometimes a problem. So their references are local variables are thus stored in each thread stack. Okay, the two different reference point to the same object on the heap though. Okay, because this one thread stack is also maintaining its own copy of object 3, another thread is also maintaining its so if this thread stack 1 from the method 1 local variable 2 manipulating of any variable through this object 3, let's say object 3 is nothing but any object B has a counter variable and it is just updating a counter variable. Okay, this thread stack 1, thread stack 2 will also updating the counter variable. So both are updating a counter variable, but this thread stack 1 is not getting the updated value, then there will be a problem here. So because these are the shared variables. So notice how the shared variable object 3 has a reference to object 2 and object 4 as a member variable. Okay, that is we have seen it. Okay. So diagram also shown a local variable which point to two different objects on the heap. In this case, the reference point of two different objects, object 1 and object 5. These are basically two different objects and they are not shared basically. Object 1 and object 5, we have seen that these are not shared basically. If you will see. this object 1 and object 5, these are also an object, but these are not shared with these two threads. So here will not be having any major issues. But the shared objects where we have, then we'll have a major problems. So basically, if both threads have a reference to both objects, but in the diagram above, each thread only has a reference to one of the two objects. So here we have a code, very simple code, which is basically we have created a thread through a runnable and then this run method. So what kind of a Java code could lead a Java memory graph? So that is basically which we are talking about. Runnable run method, we are calling a method one. So run method is a part of our lifecycle method. Through runnable, we are creating a thread. So there is a multiple ways. Either you can use a runnable, or in JDK 1.5 you can also implement a callable, or maybe you can extend the threads. Here we are creating a runnable, and then you are calling a method one. This run method will automatically getting called through a thread lifecycle. Okay, and this method one is calling through a run method, and this is basically a process. Then from method 1 we are calling a method 2. So method 2 we have a local variable integer. Here we also creating our local objects like this. So these are basically we are calling from run method method 1, and there is a one object we have created, and we are calling method 2. Method 2 has also a one integer type and objects here. So these are objects basically. And then when we are calling that this is basically a class my shared object. Okay, and we have created a instance when the memory is getting allocated, so we are creating an object for this particular class, and it is a basically static final. So this is the way basically we have created. So it is a little bit lengthy code, but you will understand the flow of the method calls basically. So this is if that one thread is basically we have created. So when you are creating a two threads, object 2, object 4, okay, so these are two objects. Basically these are two member variables in this class, and these are two primitives that is also at the class level. So these are basically stored into a, because these are class level, so these are stored into a heap. Okay, anything which we have stored or which is maintained into this method 2, that is basically a local. So that will be a locally created here, that will be stored directly into a stack. This method 1 has also, which is available, that is also directly created into a stack. So each thread maintain its own copy. So this is you need to understand. So I hope you got that. This is basically the memory is getting allocated, and you can say how the memory model looks like it. So these are basic points all about it. So I will just